Hello, this is your Unit 10 study guide video. So an infinite series has a sum of this, or a partial sum, summing up the first n terms of this. What is the sum of this series? So we're going to take this out to infinity. This is n, this is also n. When it's a tie, you use the coefficients as a tiebreaker, so it would be 4/8 or 1/2. That is different from the nth term test. This is not like what the series is. This is a partial sum. If you look back in our notes, this was the very first thing that we did in that first set of notes with geometric. All right, which of the following series could we use the nth term test to show divergence? I'm not going to write limit as n goes to infinity for all three of these, but that's what we're going to do. So for this one, the numerator degree is smaller than the denominator. That's going to go to 0. That means no conclusion, so we don't want that one. For this one, the powers are the same. We would use the coefficients. This one is 1. This one is -1. So -1. Now, if it comes out to anything other than 0, it shows divergence. So we want that one. And then this one, same thing. These are the same. So we would use the coefficients, which would be 4/5. That's not 0. So it shows divergence. All right, if x and y are positive numbers, we want an expression guaranteeing that this converges. This is geometric. A is this part and R is this part. So for geometric, this R part of it, which in this case, we don't have any numbers, it's just x and y, x squared over y has to be smaller than 1. And then what you would do is just multiply the y over. So x squared has to be smaller than y. It's going to be multiple choice. You'll be able to see from all the choices where you're headed there, but it's geometric. We just want R to be smaller than 1. Again, remember, that's the opposite for a P series. P has to be bigger than 1 in order to converge. All right, for this, I'm going to list out the first few terms. It's going to end up being geometric, but I need to see, it's not written in this nice format where it's A times R to the N. I can't see what A and R the values of those are. So we're going to just start by plugging in 1 and see what we get. So 1 minus 1 is 0. Anything to the 0 power is 1. And then down here, we will have 5. All right. And then if we plug in 2, we're going to have 2 25ths. And if we plug in 3, we're going to have 4 125ths. All right. So I can see that our first term is 1/5. And we are multiplying by 2/5. And you can kind of just look at the numerator separately than the denominator. We're multiplying by 2 up here, multiplying by 5 down here. So your sum is A over 1 minus R. And you have to keep simplifying because the answer choices aren't going to look like that. So this is 1/5 over 3/5. 5s are going to cancel, and we get 1/3. All right, which of the following series converge to 7? We're going to have to actually work all of them out and see which ones, have an answer of 7. So for this, you can put a 1 right there. A is 1 and R is 6/7. So we're going to do the exact same thing that we did right here. Our sum is A over 1 minus R. It's going to be 1 over 1/7, which is 7. So that one we want. For this one, if you do limit as n goes to infinity of this, exponents are the same, so we're going to use our coefficients. You get 7. That does not mean this converges to 7. That's your nth term test for divergence. It's exactly the same thing that we did up here. If it comes out to anything other than 0, it diverges. So we do not want that one. It doesn't converge at all, let alone to 7. And then for this one, we're going to do a really similar thing that we did for number 4. I'm going to try and plug in 1 and see what I get. That's going to be 21/2. If I plug in 2, negative 21/4. If I plug in 3, it'd be 21/8. So I can see that my first term is this 21/2, and our R value is -1/2. So if we do our sum, it's A over 1 minus R. Those negatives are going to cancel. That would be 21/2 over 3/2. And so you get 21 divided by 3, which is 7. So we want that one as well. This is the kind of thing on your test where your answer choices are going to be Roman numeral 1 only, Roman numeral 1 and 2, Roman numeral 1 and 3, So you have to go through each of these and then make your answer selection. All right, which one is not a p-series? This is a p-series where p is 5, so I don't want that one. This is not a p-series. That would be geometric, where you would have 1/5. You could do 1 times 1/5 to the n. A is 1, R is 1/5, so that one's geometric. It is not a p-series. You can rewrite this one as 1 over n to the 9th, so p is 9. So that is a p-series. And it said which one is not a p-series, so we don't want that. All right, which of the following converge? So we can rewrite this one as 1 over 4 to the n, to be 1/4 to the n. That is geometric, and your absolute value of r is smaller than 1. So that one does converge. This one, you can do a comparison. You can compare it to 1 over n to the 3rd. For that, p is 3, which is bigger than 1, so that one also converges. When you do a comparison test and it's multiple choice, you don't go through direct comparison or limit comparison. You can just do a comparison, and whatever that one does, you can safely assume this one does too, because you don't have time for all of that with multiple choice. All right, and then for this one, I'm going to do a comparison to 1 over n. Ignoring this 2, kind of like getting rid of all the extra stuff there, that is going to reduce to 1 over n. That's your harmonic series, or you can think of it as p equals 1, which is less than or equal to 1, so that one diverges. We do not want that one. All right, for what values of p will both of these converge? This one is geometric, so I want that p over 7 to be smaller than 1. P is going to have to be smaller than 7. This one is a p-series, so it's the opposite. We want this 4p to be bigger than 1. So p is bigger than 1/4. So if you put those together, p has to be in between 1/4 and 7. So again, this one was geometric. That means smaller than 1. This one's a p-series. That means bigger than 1. We just want them both to be true at the same time. All right, what series would you use to compare for this one? So I've got an n to the 4th in the numerator and an n to the 6th in the denominator. So we do 1 over n squared. I bumped the projector, so it froze. Just a second. And it didn't ask this, but that would converge. It's a p series where p is 2, and that is bigger than 1. Oh, you don't want to see me. Hold on a second. Let me pause the recording. So for number 10, which of the following series converge? So let's look at them one at a time. If you were to do an nth term test for this, you would get 0, which means no conclusion, so we're going to have to try something else. I would do a comparison test and compare that to 1 over n. That is your harmonic series that diverges. For this one, if you do an nth term test, it is going to go to 1/4, which is not 0, so that diverges, so we do not want that one. For this one, we're going to do another comparison test. If you reduce that n to the 5th over n to the 6th, it reduces to 1 over n. Again, that's your harmonic series, so that diverges. So it's going to have to be this one. For this one, you would do a comparison test to 1 over n squared. So p is 2, which is bigger than 1. Which of the following converge? And this is different. We're not going to get maybe just one answer, or we might. I don't know. We'll have to see. But this is your Roman numeral thing, where your answers are going to be Roman numeral 1, Roman numeral 1 and 2, etc. So this you can rewrite as 1 over n. That's your harmonic series. Don't want that one. That diverges. For this one, p is 3, which is bigger than 1. So that converges. For this, you would do a comparison test to 1 over, or I guess you could do an alternating series test as well. But it's 1 over n to the 1/3. And so if p is, oh no, you know what? I am going to have to do an alternating series test. Comparison is not going to be good enough. Let me get my white out. Because if it's alternating, I'm pretty sure it's going to converge. All right, for your alternating series test, and I know this is alternating because it has this -1 in there, you do the limit as n goes to infinity of everything without, I'm writing over top of my whiteout here, everything without that alternating part of it. If your denominator gets bigger and bigger and bigger, this is going to go to 0. So that's the first thing that has to happen. And then you have to show that the terms keep getting smaller and smaller. So if you do your n plus 1th term, that has to be smaller than your nth term. And this is going to be true because we're going to have a bigger denominator here. I don't know why I put a check mark, but this converges as well. That's your alternating series test. So we would want Roman numeral 2 and 3. All right, state the 3 conditions for convergence. We just did that. Number 1, it has to be alternating. 2, your limit as n goes to infinity for your series has to be 0. And then your terms have to be getting smaller. They have to go down to 0. All right, use your integral test. Usually for integral tests, they're not shy about saying use the integral test. That's one that you don't usually have to guess on. All right, so we're going to do limit b goes to infinity, 1 to b, and then we're going to put x in here for this. So 1 over e to the x squared. You know what? I'm going to, instead of 1 over, I'm going to write that with a negative exponent. So we're going to do e to the negative x squared, and then that's over x cubed dx. So this is going to be a u substitution. I would actually write this one out in this case. U is going to be this negative x squared. That derivative is going to be negative 2x. Or, no, I'm sorry. I put the negative in the wrong spot. My brain isn't working this morning. I am so sorry. I haven't had enough coffee. This is x to the negative 2. So sorry, it's in the denominator. So it's e to the x to the negative 2. Hold on, I need to get my thoughts organized here. I get how I read that wrong. It looks like the e is in the denominator. I should have put parentheses here. It's e to the power 1 over n squared. So the n squared is the only thing in the denominator. It's e to the x to the negative 2. So sorry. It just got all jumbled together there. I thought it was 1 over and the e was in the denominator. It's not. I should have put parentheses. That's my bad. All right, so if we do the derivative of this, it's going to be negative 2x to the negative 3rd, which is going to look like this. So that's taking care of that x to the 3rd that's in the denominator. We're just going to need a negative 1/2 adjustment number to get rid of that negative 2. So I need that, I should have put that negative 1/2 in front. All right, so this is taken care of. We substituted that out. We took care of the negative 2 with our negative 1/2. What's left is e to the u. And conveniently, that is itself. It's its own derivative. It's its own antiderivative. So it would be e to the power x to the negative 2. So I'm going to put my parentheses there so I don't mess that up again. Such that 1 to b. Now we're going to do upper boundary minus lower boundary. Oops, I didn't realize I went off the screen there. All right, so if we plug in b, it's going to be the exact same thing except with b in there instead of x. And then if we plug in 1, we're going to get negative 1/2 e. If you plug in 1, 1 squared is 1, 1 over 1 is 1. I guess you could put a 1 there if you want to. And then as we go out to infinity, this denominator is going to get larger and larger and larger, which means this portion is going to go to 0. These negatives are going to cancel. Anything to the 0 power is 1, and then times negative 1/2 is negative 1/2. The point is, since we got an answer, and this is a number, the series converges. If you get infinity, then divergence. So whatever the integral does, the series does as well. All right, use the ratio test to show whether this series converges or diverges. So we're going to do limit as n goes to infinity. We're going to plug n plus 1 in here. So n plus 1, and then pi to the power 3n plus 1. I'm actually going to go ahead and distribute that 3. So that'll be 3n plus 3. All right, over 40 to the power n plus 1. And then that is all over the series. So n pi to the 3n over 40 to the nth. All right, now I'm going to flip over the fraction. Dividing by a fraction, same as multiplying by a reciprocal. And then we'll be able to start canceling some things out. Okay, let's see. Let's do the pi's first. So if you divide, that means you're subtracting. We would have 3n plus 3 minus 3n. So it's going to just leave us with pi to the third times n plus 1. And then down here, same thing. You can think of those as subtracting, or you could just go, oh, I have one extra 40 that's in the denominator, and then we also have this n. So the powers are the same. We're going to use the coefficients, and it's going to be pi cubed over 40. And we just have to see if that's bigger or smaller than 1. So pi is roughly 3. It's 3.14, but 3. 3 cubed is 27. So you could think this is roughly 27/40. And the point is that is smaller than 1. So smaller than 1 means converges. Equals 1 means no conclusion. Bigger than 1 means divergence. All right, which of the following would you use the ratio test for? This one you would do a comparison test. You would compare to 1 over n cubed, and you would be like, oh, that's a p series. This one you would compare to 1 over n, again, p series, or that's the harmonic series. This one you would compare to 1 over n to the 6th. So those would all be a really simple comparison test. This is the one where you would need a ratio test. Ratio test is kind of like your Hail Mary, like nothing else worked. And it's you have no other options left. This would be really simple. Converges, diverges, converges. This one you'd need to do a ratio test. All right, so consider these two series. We have A and B. If A converges, what must be true? All right, so if B is smaller than A and A converges, then B also converges. This is your direct comparison. And again, it's going to be written as multiple choice. You just have to read through the choices and find the one that's right. So if A diverges, so we want this to be the other way around now. If A is smaller than B and A diverges, then B also diverges. So it depends on which one is smaller than which. And again, it's going to be written as multiple choice, and you'll read through your options and pick the one that's right. All right, so does this series converge absolutely, conditionally, or diverge? So first thing we're going to do is look at the absolute value, because if the absolute value converges, then it converges absolutely, and then we can just kind of be done. So that would be 1 over n to the 5th. P is 5, which is bigger than 1. So if the absolute value converges absolutely. If you get that the absolute value diverges, then you look at the series itself. If that converges, then it would be converges conditionally, which is actually what we're going to look at for this one. Which of the following is conditionally convergent? So if you did the absolute value of this, you would get 1 over square root of n, which is n to the 1/2. P is 1/2, which is smaller than 1, so that diverges. The absolute value diverges. So if you look at the series itself, if you did an alternating series test, it would converge with your alternating series test. So since the absolute value diverges, but the series itself converges, this is the one that is conditionally convergent. So we got lucky and it was the first one, but let's just look at the others. If you did the absolute value of this, you would get 1 over n to the 4th. P is 4, which is bigger than 1. This one converges absolutely. For this one, you would do a comparison, or no, you would not do a comparison test. You would do an nth term test if you did this limit as n goes to infinity. Here, I'll go ahead and write it out. Of all of this, you would get 1/4. That's not 0, so this whole thing just diverges. So we don't want that one. All right, and then for this one, you would do a comparison test. For the absolute value, you would do a comparison test to 1 over n to the third. P is 3, which is bigger than 1, so that converges absolutely. So I was just showing why all of those were not the answer, which you would not need to do necessarily on your test, obviously. If it's multiple choice, then you get the first one on the first try, then that's your answer. Okay, onto our free response. State the conditions necessary to use the integral test. We need your function to be positive, continuous, and decreasing. All right, so those are your conditions for that. Then use the integral test to show that this converges. So they're kind of telling you it converges, which is sort of nice. Be careful, this one's not 1, it starts at 0. So just make sure you put a 0 there. And that would be e to the negative 3x dx. You can write out the u substitution if you want. This one's a little bit less complicated. I just know I'm going to need a negative 1/3 for that. And then it's just going to be itself. So I just kind of slapped a negative 1/3 out front there, such that 0 to b. I'm going to do upper minus lower. So if I plug in b, this is going to be negative 1 over 3 e to the power 3b. And then if I plug in 0, anything to the 0 power is 1 times negative 1/3 will be negative 1/3. And then if you evaluate the limit, this denominator is going to get super, super huge. So this first part is 0 and then plus 1/3. So since we got an answer, converges. But they told us it converged, so. All right, use the limit comparison test with this series to show that this series also converges absolutely. Wait, hold on, let me read that again. We want to do a limit comparison. Oh, okay, I get what they're saying. So this is the series. We want to compare it to this series. So they're telling you which one to compare to. And we already showed that this one converged. Like we literally just did that. So we want to show that this converges absolutely. So we're going to do our limit comparison test. We already showed this one converged. That's what we did in part A. So we are going to put, it doesn't really matter which one goes in the numerator, which one goes in the denominator, but, and we're absolute valuing it. So this is just going to be 1 over 2e to the 3n plus 4, and then over the one we're comparing to. So they're kind of just telling you what to, it's sort of like do a comparison test, but they're telling you what to compare to. So we're going to multiply by the reciprocal. This is e to the 3n, this is e to the 3n, that's the same, so we're going to use the coefficients, and it is going to come out to 1/2. If you did it the other way around, it would come out to 2. The point is we got a limit that is finite and positive. So we're going to say limit is finite and positive. So this series converges absolutely. So it was a limit comparison. We just showed the limit. They told us what to compare to. All right, if the first 3 terms are used to approximate the sum, what is the alternating series bound? So if we do the first 3, it means that your error has to be less than whatever the 4th term is. So essentially all we have to do is plug in 4. So negative 1, well, you would absolute value it anyway, but that's going to be positive 1. And it would be 2e to the 12th, 3 times 4 is 12, plus 4, whatever that is. That is just worth 1 point on the test. Everybody should get it. If it says the first 5 terms, you would plug in 6. If it says the first 7 terms, you would plug in 8. Your error is less than or equal to the next term. I am going to skip this one just for a second. We're going to do 21 and 22. These are calculator allowed ones, just so we can finish up all the series stuff. I threw this on here just in case series aren't your thing, then you can get some points from a different type of problem. And also it's good review. All right, so for the alternating series test, sum of the first 7 terms is used to approximate the sum. What is the series? Okay, so same thing we just did. We're going to plug in 8. Actually, you don't even really need a calculator for that. It's going to be 1 over 3 times 8 is 24, minus 2 is 22. All right, we didn't even need a calculator. A lot of times calculator ones, you don't even end up needing the calculator for them. All right, this series is approximated by a partial sum S sub k. We don't know what k is, though, so I don't know how many terms got added up. I think that's what they're going to be asking. What is the least value of k? All right, so how many terms do we have to add together for the alternating series bound to be smaller than 0.0007? So let me share my screen. We'll go to the calculator. And we're just going to kind of test this until we get it to work. So I'm going to plug in, it was 1 over 3 to the n. So I'm going to do 1 over 3 to the 4th. Let's see. What does it have to be smaller than 0.0007? That is not, nope, almost. Almost 0.001. I need there to be 3 zeros there. So probably this next one. There we go. 0.0004 is going to be smaller than 0.0007. Now here's the thing. That's the 7th term. So that means we want to add up the first 6 terms. This is the n plus 1th. It's the next term. So the answer to the question is 6. We want to add up 6 terms because the 7th one gives us an error smaller than that. All right, so let's go back and do this one that has the table. So the amount of water in a vase is given by a twice differentiable, just means everything's fine. You can take all your derivatives. W is measured in liters, time is measured in seconds. Notice this is a derivative, liters per second. So these are values of the derivative. Concave up, that's going to come up, so we'll need that at some point. Selective values of the derivative are shown. The amount at time 3 is 0.5. That's an initial condition. So we're going to need that at some point as well. So use a tangent line approximation at 3. There it is. We're going to need a point and a slope, and our point is 3, 0.5. Slope comes from the derivative. I want the derivative at 3, so that is 2.8, and we're going to write our equation. And then it says, use it to approximate 3.1. So y is approximately, oh, oops, I need another equal sign. We're going to just plug in 3.1. And then I'm going to add over that 0.5 to the other side to get y by itself. Please do not simplify this. It's non-calculator and it's free response. Just leave it alone. If you mess it up, it's going to be wrong. Okay? And then we want to know if this is an overestimate or an underestimate. That comes from this concavity. If your graph is concave up, it's going to look like this. If you draw in a tangent line, do you see how the line is below the graph? So we are going to say underestimate because W of t is concave up. All right. Use a right Riemann sum with these 5 subintervals. 1, 2, 3, 4, 5. And it says indicate units of measure. If this is liters per second and we're doing an integral, it's going to take us back to just liters. So it's just, we're accumulating water. We're accumulating how much water is in the vase. Right? So first subinterval is 3, and it is a right sum, so I want the 2.8. Plus, all right, from 3 to 6 is 3, and then the number on the right is 2.4. 6 to 7, that's 1, and then times 1.9. From 7 to 11 is 4, and then the number on the right is 1.3, and then from 11 to 14 is 3, and then we want 0.7, and it's all of that liters. All right, is that approximation an underestimate or overestimate? That comes from what these values are doing. 3, 2, 2.4, 1. Okay, these values are decreasing. I just always draw a line. This is left, this is right. We did a right sum. See how that's lower down? So we're going to say underestimate because W prime is decreasing and this is a right sum. All right, and then the last one, we are going to write this as a definite integral. Basically, it's just like a puzzle where you're getting all the puzzle pieces in the right place. Let me write off to the side how this works real quick. So 1 to n, in this case, it's w prime. But you usually have this value where you start. This is like your lower boundary. And then you have your delta x, like what you're changing by. And then that gets repeated right here. So this would be your lower boundary plus, and then how much you change by. So that's like the distance of your interval. And it's just your function. So like inside of here is just going to be w prime of t dt. Like that's just what this is. In this case, there's nothing being added there. Do you see what's inside? And you can see this 8 over n got repeated. But what's inside of there is nothing plus 8k over n. So our lower boundary is 0, and our delta x is 8. So 0 to 8. And this is the answer. That's literally all that you have to do. Instead, pretend there was a 1 there, and this was 8. You would have from 1 to 9. Your distance of your interval would still need to be 8. So it's wherever you're starting plus, and then you just add that together to get where you end up.